Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way.
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way.
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
Yeah, hello everyone. Am I properly audible and visible? Can you please confirm in the chat box? Hello everyone. Am I properly audible and visible? Can you please confirm the same in the chat box? Hello Aman, how are you? Okay, so let me present my screen then. Just okay, is my voice everything is fine, right? Okay, so let us begin then in that case. Yeah, so let me tell you a bit of introduction about the series. So this is the Graph and Tree series on GFG Practice channel. So basically, today is the third session, in fact, of tree series. We had a graph series in the month of December, and today will be a practice session. We discussed about various traversal techniques of tree in our previous two sessions. Okay, hello Chandra. Okay, and I would request everyone to kindly um, yeah, kindly like the session as well as subscribe to our channel because we are planning to release a lot of great content over the next few months. In fact, a dynamic programming series is also running parallelly along with the tree series as well. Okay, so this was about the present tree series. Hello Naikaj, how are you? So today will be a practice session, in fact. So just a minute, let me get my stuff ready. Yeah, so yeah, I would request everyone to kindly stay with me till the very end so that you guys enjoy the session. And let us begin then. Okay, so let me give you a small introduction about myself. My name is Gaurav Kumar Shaw, and I am presently in my third year. Okay, yeah, my branch is Industrial and Systems Engineering. Okay. Hmm. Okay, so let us begin with our problem. So, Naikaj, I hope you were there in my previous session, and in my previous session, I discussed about the traversal techniques such as the pre-order traversal, in-order, and post-order traversal, and also we discussed the recursive formulation, right? How to solve those problems in recursion fashion. So today, what we will do, we will try to look into the approach of iterative approaches. Okay, and we also just segregated our traversal into two parts. The one involving DFS, which is depth first search. So what happened in depth first search was that basically the concepts like pre-order, in-order, post-order all were using the concept of depth first search, but our level order traversal uses the concept of breadth first search. Okay, so that was clear. So we solve some problem also. Yeah, Naikaj, okay. So let's look into the iterative part, because what happened in interviews basically is that the interviewer are always not happy with the recursive code. They always want that you give them an iterative code. Okay, so in that case you should know the iterative code as well. Okay, so let's look into that. So first we will study is the iterative pre-order traversal. So yeah. Hmm. So basically, can anyone tell me what data structure we will use to solve the iterative pre-order traversal? Anyone? Yeah. So basically, what happens in recursion is that since in pre-order we have to first go to the root, then we have to go to left, and then we have to go to right. So what we were trying to basically do is that so we are recursively trying to call the root. Root was basically the data. So whenever we are entering into a recursive formulation, we printed the value of the data, and then recursively called the function for the left subtree, and then again recursively called the function for the right subtree. But this time what we will do, instead of recursively calling, we will use certain data structure that will help us mimic the same concept of recursion. So do you know that in case of recursion what happens, we take use of the auxiliary stack space of our computer system, right? So we have to try to mimic this entire thing, the mimic the concept of auxiliary stack space. So in that case what we will do, we will use the basically the stack data structure. Sumit is correct. Okay. Hmm. So we will use a stack data structure because we have to mimic the idea of recursion with the help of stack data structure. So I have already written the yeah. So I've already written the pre-order traversal of this graph. Since I have to print the root first, so root is 1. Then I go to the left. Okay. So after I go to the left, I print the root that is equal to 2. Again I go to the left 3. So 3 I will print 3, but 3 doesn't have left or right. So it will come back to 2. It will go to the right. So it will print 4 now. 4 will go to left. It will print 5. Then it will print 6. But 6, what happens in 6 is that the number 6, it doesn't have a right or a left. So it will go back to 1, and then it will go back to its right, that is 7. Okay, so after it goes to 7, it will print 7. So this will be my order 1, 2, 3, 4, 5, 6, 7. So what exactly happens here? We will use a data structure called stack just to implement the same idea which we were using with the help of recursion. Okay, so let's see then. So I have already written a pseudo code here. In fact, it is a complete code here. Basically what is happening here, first of all we have to declare a stack. Okay, and then since the first point is the root, we will push the root of our tree into the stack data structure. Okay, so this is the first two lines of the code. After that what we'll do, yeah, we will run a while loop, and then in the while loop what we will do, we will check whether my stack is empty or not. So if it is not empty, I will run my while loop. Then what will I will do, I will take the top element of my stack, so which will basically form the root. So what will I do, I will push that into my answer vector, because the first thing that I'm doing is to print the root. So I print my root, and printing is basically pushing it into answer vector. So I push the value root of val. So this is the root of val, and I push it into my answer vector. After that I go to the right part. Now why I am going to the right part, this is a question now, because see, so in pre-order traversal, after we print root, we have to print the left part. Okay, now what is the stack data structure? Stack is basically whatever it is going inside in the last in first out. So if left part is going first, then it should and right part is going later, then right part will come first. Okay, and in pre-order traversal we have to print left part. So basically since we have to print left part first, we will push the left part in the end. Okay, so that is the reason we are pushing the right part first, because we have to print the right part at the last. Okay, so whatever stack, whatever we are entering into a stack, it comes out at the last. First in last out kind of data structure it is. And in pre-order traversal we print the left part first, so that is the reason we are pushing the right before left. Okay, yeah, Naikas, you can also use a queue, but this is a general type of understanding, general type of code we are writing. See, basically the thing is queue is also a data structure. We can also use a queue data structure also, because it will also mimic the same thing. Okay, so this part, I hope everyone understood it, right? Why we are pushing the right part in the beginning and then the left part. Any doubts here? Initially we put the right first and then the left. After that what happens, we will run the loop as long as our queue is not empty, and finally return our answer vector. Okay, so let's look into an implementation of the same question. This is the practice of the pre-order traversal. I am putting the link in the chat box as well. Okay, so let's see. This is a pre-order traversal. So this was our implementation of the pre-order traversal, which we did in case of recursion. Okay, so let me comment the code out. This was the code of our previous session. Okay, so I'm commenting this code out. Now let's look into in-order traversal. Okay. So this is exactly the same thing. We initially declare a stack. We push the current, that is the root of our tree, into the stack initially. Then as long as the stack is not empty, or in fact we'll run the while loop. Take the top element, push it into our answer vector, pop that element. Go to the right, push the right. Go to the left, push the left. Why we are pushing the right? Because we want to print left first. Okay. So let us submit this problem and see whether it is correct or not. Yeah, hello. I hope am I properly audible and visible. So basically, in the question, it was given root, and I was declaring a variable called cur. Okay, so let's see. I hope this should work. Yeah. So as you can see, all the test cases have passed. So therefore, this question is correct. Any doubts in this question, or should I move ahead? Naikaj, we can also write a queue for queue, same code using the queue as well. Okay, so I'm showing you just a minute. Let me show you how. So let's try to look at the editorial part of the question. There you will find maybe multiple ways to solve the same question. Okay, it's not mentioned here. So okay, so let's see what you can do here is that let's look into the article on GFG. Okay, so first is basically the recursive part. Okay, then time complexity overfn overfetch where h is the height of the binary tree. Okay, so this part is the recursive part which we just discussed. Okay, so a code is not present in this article as well, but yeah, exactly. You can actually do that without stack as well. Let's write uh, without stack. Maybe we'll get a hmm. Session. Is it on basic problem or advanced? Mostly, we will be discussing the topics and we will be doing questions related to that. So this is an interview focused series. So it will be mostly on basic to medium level questions and not advanced. We will be having an advanced level question series after the series ends. Okay, so make sure you can attend that, but it is an introductory or a beginner level series only. Okay, yeah, iterative approach is more efficient than recursive approach. Can you tell the reason how exactly iterative approach is more efficient? Okay, so we are done with the pre-order part. So we will move on to in order and post order again, but let's look into level order traversal. Okay, so the best part of level order traversal is that it is utilizing the concept of breadth first search while writing the code. Okay, so as you can see, I have already drew a tree here. So on this tree, give me 1 minute. I need to change the background of the yeah. Okay, yeah. So let's continue then. So, level order traversal uses the concept of breadth first search. And why exactly breadth first search? Because we have to basically print our entire tree in level wise fashion. First, we will print the node 1, then we'll print the node 2 and 3, then we'll print the node 4, 5, 6, and 7. Okay, so see, we are going level wise. Okay, so first, this is the first level, then the second level 2 and 3, then the third level 4, 5, 6, and 7. So, can you tell me, since we are using the concept of breadth first search, which data structures we will use? So Naika is saying because it is not create any stack space as well call fun function to take some time, but in iterator it is a kind of overhead are not there. Yes, exactly, Naika. This is a perfect reason for that. Yeah, so tell me the data structure. Yeah, we will use a queue data structure, and one more data structure we will use basically to store our answer. So that will be a vector of vector data structure. Okay, because see, I'm saying you that we have to print the entire thing level wise level. So first level is 1, the next level is 2, 3. So how we will store each and every level? We have to each and every level is a vector in itself, and there are multiple levels. So vector of vector. So we stored every level, all the values in a level in a vector, and we will store that vector onto another vector. So we will need another data structure called vector of vector to store our answer. But the important data structure is queue because we are implementing the breadth first search algorithm. Okay, I hope this part is clear. Hmm. So let's move to the next part. So yeah, So level order traversal. So tell me, let me just put a code. Let me just put the code here and then explain it to you all, and then we can proceed ahead. Okay, so in the entire month of December, we did a lot of problem related to BFS. So I'm sure everyone can easily write the BFS code. Okay, so that is the reason I will just directly move on to the coding part. Hmm. Okay, okay, so you can see the code part, right? So the first thing that we have to do is declare an answer vector, which will help us store our answer. Yeah, so this is basically helping us store our answer. After that, we will declare a queue data structure and we'll push our root into our queue. After that, we'll run a while loop. So this while loop is basically running as long as our queue is not empty. So what we are taking, we are taking the first part of our queue. Hmm. Okay, so we are taking the front of our queue. We are going to the left part and we're checking whether the left part is null or not. If it is not null, we'll just push it into our queue. Okay, so this is the part. And then we are going to the right part. If it is not null, we'll just push back into the queue. So after we are done with this, we are just putting it into our answer vector. Okay, so there are other ways of implementing the same thing, but we will try to submit this code first. Okay, and then check for other ways. Okay, so see, in this question, what we did, we tried to take the front element of our queue data structure, go to the left, go to the right, push it into our queue. Okay, so initially we have one, so one is into the queue, one will be pushed into the answer. So after one, what happens? We are basically going to the left of the tree, right of the tree. This two and three will be pushed. Now two and three are in the queue. Now whenever I'm processing the node two, I am pushing the next part of my queue, the left and right of the node two, which will get inserted into the queue. Okay, so after that, in queue, what is happens in queue, whatever elements are coming in previous first in the queue, it will only go out first, first in first out. So after two, three will be processed, and the number three will be inside my answer vector, and then the roots, the children of three will be there. Okay, so this is how the implementation of level order is getting done. So I hope you can see this screen here. Let me just have a code there. So this should be node, and this should be root. Okay, so this should be root. So there's a small compilation error. Okay, so it should be node star. So meanwhile, how is my session progressing? Can I have a bit of little feedback here? Am I properly audible and visible? And apart from that, is my explanation clear? Nikach, can you please kindly review it so that maybe I will change a bit or slow down a bit. So here it is saying struct node no member named val. Okay, because in the GFG platform we have data here, so this should be data. Okay, this should be data. Let me submit this code. Okay, Nikaj, that's very well. So as you can see, all the test cases are passed. So this code is also correct. Apart from that, okay, yeah. So this part is done. Now the question may arise that someone is asking you that you just printed the level order traversal. Now I want you to print the level or you have to print the level number as well. Okay, so just have a look at the screen. I tell you that print level order traversal. You print 1, 2, 3, 4, 5, 6, 7. Now I am asking you print the level number. So what you do, you print the number 2 and 3, and you mention that 2 and 3 belong to level number 2, 4, 5, 6, and 7 belong to level number 3. In that case, what you will do? Any ideas, anyone? Nikas, you can say you can take level variable. So will it help you? Just one variable, will it help you? So basically, I just said in the so basically, I just said that when I was starting this problem, that you can declare another vector called vector of vector. So what you will do, you push initially one into the queue, then you run a while loop to across all the elements in the queue. So that is one level. So you store that in a vector, and once you are processing that, you just go to the left and right of each and every node and store it into the queue. So initially one will be there, and after you process 1, 2 and 3 is entering into the queue. So you store all the values 2 and 3 into the vector. Now once you're processing 2 and 3, so 4, 5, 6, 7 will come to the queue. Now you put 4, 5, 6, 7 in another vector. So what you are doing in your vector of vector, the first level is getting stored as 1, the next level is getting stored as 2 and 3, then again the another level is getting stored as 4, 5, 6 and 7. So in this way you can print the level number as well along with uh, the nodes present in the level. Yes, like that, you can also do it in this fashion. Okay, so this is the idea that I wanted to convey using this problem. I hope this part is clear with everyone. So let's proceed then. Okay, so now is the iterative in order traversal. So in order is the most easiest part of the traversal technique. And meanwhile, if we have 7 people with me right now, so I will request everyone to kindly like the session, like the streaming session, subscribe to our channel as well, because we are planning to provide great content over the course of next few months. Apart from this tree series, a dynamic programming series is also going on parallelly. You can check that out. And apart from that, yeah. So basically, I am coming live on every Monday and Tuesday with a tree series. Today is a practice session, and this will continue for the entire month of January. Okay, so I hope you all stay with me. Okay, we have 10 people with me right now, and I would request everyone to kindly be with me till the end. The session aren't very long; it's mostly till 50 minutes or so on an average basis. Okay, so that was it. Now let's talk about the in-order traversal, iterative in-order traversal. Now, in-order is the most easiest part of all kind of traversal. Why so? Because in what happens in order, we go to the left, we keep on going to the left. Amit Ranjan is asking, where is the last class? I'm not able to get your question. Our last session had on last week. Okay, so we are coming live every Monday and Tuesday, 2 sessions in a week. Okay, so how can I get last class? You will find the recording in the GFG practice channel only. Just go to the playlist of the channel and you can just get all these sessions. Okay, in fact, everything that has happened live till now, we initially used to, before this session, we used to stream a playlist called SDE Sheet, in which we did is to check, solve 3 questions live every day, and over 30 consecutive days we did. So that was like 30 into 390 problems we solved in that playlist. That was one of the most popular series of the channel, and we're trying to bring similar kind of series in our in future as well. Okay, so this is it. Now, this part is done then. Let's proceed to the next part. So, in iterative in order, what is happening? We initially have to go to the left, keep on going to the left, and then after there is no left, we'll print it. Then we try to go to its right. So, what happens? Say, let's say we are trying to implement the recursive code. So, initially we start with 1, recursively call for 2, then again recursively call for 4. So, what was happening? This 1, 2, 4 all were getting stored in the auxiliary stack space of our computer, right? So, in order to just implement the uh, exact same thing, we will declare an external stack. Okay, so we will declare a stack, and whenever we are trying to access a node, let's say initially we access node 1, we put inside the stack, then we go to its left. Okay, we again push the node in the stack, then again left, we again push 4 in the stack. Now when I'm at node number 4, I see I do not have a left to go. So what will I do? I will take the top element, I will print, I do not have a left to go, I will print that, I will return them, again try to go to its right. So this is the entire concept of going to the left, then to the root, and then to the right. Now we will implement the same thing using stack data structure. Okay, so just a minute, let me put up the code here, and I can directly explain it using the code. Okay, so this is also the similar kind of approach here. Just a minute. Okay, so let's see the code here. So as I said, we will declare a vector of in order. Okay, after that, what we will do, we will try to okay, so we declare a vector of in order, and then we declare a stack as well. Okay, after that we run a while loop, and the while loop will keep on running until and unless it is getting a break statement. The first thing we will do, we will check whether it is null or not. If it is not null, I will push it into my stack and then go to the left. Push it into the stack, go to the left. So keep on going to the left until and unless there is there is actually a node to push to the stack. Now, if there is no node, okay, so what will happen? I will come to the else part. So once I come to the else part, okay, so let's say I come to the else part, and in this, then what will I do? Now there is no right or no left. So in that case, what will I do? I will just push back into my data structure in order, okay, because in order is the answer vector. Okay, I will push the current of data. Data I will push. Now I will pop that element. After that, I will try to go to its right because the idea is that we will go to the left. After left, we'll print the root. After root, we'll print the right. So in this fashion, we'll proceed. Okay. Now what will happen? I will check if at any point of time if the stack is becoming empty, because what is happening, we are trying to access the top element. So it may happen that the stack has become empty, and in that case, the top element will give a error. Okay, segmentation fault will be given. So in that case, what will happen? I will just check previous to it if it is empty or not. If it is empty, I will just break out of the while loop. It means that our entire traversal is over. Okay, so this will help us solve the question. So let us just submit this problem in the GFG portal and then try to understand. Okay, Naika, you can try it on your own as well. So we have 10 people with me right now. I would request everyone to kindly like the session and subscribe to our channel. Um, and you can meanwhile also one more thing is that resolution days are going on, and you can check out the courses present in the description. Okay, so this will help you. You can get great discounts, not getting iterative approach. Okay, when I will type the code there, you will see it. Give me a minute. Okay, so follow my words very carefully. So the idea of in-order traversal was that, yeah. So this was a recursive code. So let me just hmm, let me just comment this part out. So this is the so let's submit this problem and we'll check. Yeah, so this was the problem that I was trying to show. Okay, I'm Ranjan. Just a minute. I'm explaining it to you again. So listen to my words very carefully. You will understand it. Okay. So the concept is that in order traversal, we initially go to the left, then we print the route, and then we go to the right. So what we are doing, we have a tree, and then initially we will keep on going to the left until and unless there are no left node. So this is the reason I am writing if node is not equal to null, I will push that into my stack and then go to the left. So I will keep on going to the left and keep on pushing it into my stack. So once I reach the leaf node, I see that there are no longer any left node present. So in that case, what will I do? I will pop that element out, push it into my answer vector because it is a part of my answer now. Then go to the right. Okay. Again, I will go to the right. This entire thing will repeat itself. So if there would happen to be a left of the right, then again it will get pushed into the stack. So before I am checking the top, I will just check if it is not equal to the size is equal to 0. I will just break out of my while loop. Okay. So clarity here, Amit, did you understood? I should tell you that you should first check out the recursive implementation. So once you get the recursive implementation, that will be helpful for you to solve the iterative implementation as well. So what you can do, you can just note down a tree, and then after that, let's say I'm showing you how. So let's say this was the okay, so this was a tree. 1, then 2, 3, then 4, 5, and then 6, 7. Right. So initially what is happening? You do a dry run. Initially we are putting 1 into the stack, then 2, then 4. After 4, we see that there are no left, so and also no right. So I will print 4. Then it will go back to 2. Hmm. Okay, so 2. And 2 will come to its right, that is 5, and then left 6. And 2, then 6 will be printed. After 6, it will print 5, it will print 7. This is how the entire stuff will work. Then 1 and then 3. So what I want you to do is basically draw this tree on a what was segmentation fault? Okay, I'm telling you, just a minute. Why while one? Okay, yeah. So what in order to understand the algorithm properly, what you can do, you can just draw the tree, try to dry run the tree on the alcode. You will understand it. Now the first doubt of Amit is why while one. So basically, what is happening is that you put a while one is that is a true condition. Your while loop will keep on going until and unless there is a statement that is breaking from the while loop. Okay, so in the code, if you see the first see this part, I'm putting a checking condition that if s of empty, so if my stack is empty or not. If it is empty, then I'm breaking from the while loop because my while loop should keep on running until and unless I have an element in my stack. Okay, so that is the reason. Since I'm putting a breaking condition outside in the else part, there is no need to put it in the while loop, right? So when I'm in my else part and if my stack is empty, it means that my iteration is over. I can just break out of the loop. Okay, so this is what it is. Now the segmentation fault I meant by that. See, in the else part there is a code called check this out. Okay, so in the else part, this one, node is equal to st dot top, this line. So what does this line mean? I am trying to access the top element of my stack. But if let's say the stack is empty, so in that case, I will get an error, right? Because there are no elements on the top and I'm trying to access the top element. So in that case, what I'm doing, I am saying that I am putting this checking condition before this code. Before I'm accessing the top element, I am checking this condition. Okay, because let's say if I'm putting this line of code somewhere below the top and node equal to st dot top, it will not work. Okay, so before I'm accessing the top, I have to make sure that there is a top to access. Otherwise, it will give a error message. So that is what I was trying to say. Always put this checking condition before you start writing the next part of the code. Okay, so this part is important here. So as you can see, all the test cases have passed. So therefore, this problem is correct. Okay, so this part is done. Any doubts here? Yeah. So I hope everyone got it. So we have 10 people with me live. This is quite a healthy audience. So I would request everyone to kindly like our channel, subscribe to this, like our streaming, subscribe to our channel as well. Okay. And apart from that, this tree session will be going live every Monday and Tuesday, and we are also having a dynamic programming series as well. Okay, so quite a lot of good content that will help you in preparation to your interviews for your next internship and placement. So, can you all write in the chat box that are you trying to grab an internship in the next summers? So, in which year in college you are in right now? Amit, Nitin. Naikaj, I know about Naikaj. Amit and Nitin. Naikaj is in first year of BCA. Yeah, thank you, Naikaj. Yeah. So, Amit and Nitin, so tell me in which year of your college you are right now, and in fact, if you are in your second year or in I know about Sumit as well. Sumit also mentioned. Okay, so you are in your third year, Amit. So, in your third year, it means that you will be trying to grab internships for your next summer, right? So these questions are very frequently asked in interviews. Okay, because iterative in order, iterative pre-order, and iterative post-order, iterative level order. All these are very very important from interview point of view. So make sure that hmm, you know these concepts very well. Okay, so this was about iterative in order. So let's try to do iterative post order. We did pre-order, in order, iterative post order traversal. Yeah. So let's look into an article first. Okay, so this is the GFG practice channel. So how exactly we will do it? Okay, so before we come to the part here, let me just explain it to you here. Okay, Naika, that's very well. You are preparing for your interview. Okay, so let's look into the part of. I hope everyone knows about how to proceed. We have to go to the root and then the left and then the right. Okay, so this implementation requires using two stacks. Okay, so we can also do by one stack, but in fact we will take help of two stack. Okay, Naika, once your time will come, you can definitely apply. So meanwhile, what you can do, you can try to improve your development skills. And once you are thorough with your development skills, you can apply at startups and do internships in that fashion. Okay, because it's difficult to get a product-based internship in your first year. Okay, it's so this part is hmm. Okay. So let's see what we do here. First of all, we will create a vector, okay, called post order, which will store our answer. Okay. So after that, we will declare two stacks. The first is S1 and the next is S2. So initially, we will work with stack S1 first. So we'll push our current element into our stack, take the top element into our stack, pop that out, then push the same element in the stack 2. Then go to the left, go to the right, push the current into the left and the right. Okay. Now the thing is, we initially put the root, then what is the idea of post-row traversal? Post-row traversal is left, right, and then the root, right? Okay, first we will go to the left, then we will go to the right, and then we will put the root. Okay, so that is how this will process. And after the first stack gets empty, we will whatever remains on the top of it, we will put it into our post order. Okay, so in this fashion, we will be able to solve our question by using two stacks. So let's try to submit this code and check. So you need to complete your degree and then you can apply. No, I guess it's not exactly like that. Basically, what happens sometimes you can apply when you are in college as well, but that will be an internship and not your full-time offer. Okay, so you can try to do two or three internships in your college, which will help you strengthen your uh, resume, and you can get That will help you to get full-time offers as well. So there are few errors here. Let me see. So in fact, this part is called. Let's see if this works or not. Okay, so this doesn't work, so I have to put it capital N. Okay, and this will be capital N again. This will also be capital N again. Okay, and this should be current. So let me just write CURR. After that, I hope everything is proper and I won't face any errors here. Okay, yeah. So as you can see, all the test cases have passed. So therefore, this question is correct. Okay. So today we saw the iterative version of all the traversals in order, pre-order, post-order, and level order as well. So in the recursion part, what happened was that in order, pre-order, and post-order were depth first search, and level order was breadth first search. So level order is basically an iterative version in itself. Okay, so level order will help us, but the remaining three pre, in, and post order, they were kind of DFS based traversal. So that was a recursion. And in our last session we saw the recursive code. So this time we saw the iterative code. So we have 16 people with me live right now. I would request everyone to kindly like this session and subscribe to our channel. Okay, so apart from that, yeah, we will be seeing again seeing tomorrow. We will be having another practice session tomorrow. Okay. Now Sumit is asking how can I understand if I'm good enough in DSM. So basically, what you can do, you can try to attempt contest on lead code. There is an excellent contest called bi-weekly contest and weekly contest as well. You can try to appear in those. If you are able to solve all the questions, maybe three questions out of four as well, and that is it means that you have a good grasp on DSM. Apart from that, what you can do is that try to solve other platforms as well, code forces or codeship. Code forces will be mostly about logical thinking rather than data structures and algorithm. But in fact, you can try to solve at coder also, and you can try to give mock interviews with your friends. So Sumit, what you can do at GFG, we have something called as live mock interview, in which mentors at Geeks for Geeks try to take mock interviews of people who are filling up the form. So just go to the YouTube and just check out a mock interview session. Go to the description and try to fill the form. You will get your mock interview scheduled. Okay. So in fact, that is one of the reasons, and it will also kind of help you put up a check on how well you are able to understand the concept, and then how well you are able to communicate it to the interview. Okay, so this all will give you a good indication that how well you are prepared for your data structures and algorithms. Okay. So this was from my side for today. We will again meet tomorrow then. Okay, yeah. Amit is asking to visualize a code via the tree. Yeah, Amit, what you can do, Amit, you can write a code by yourself. You can do the same thing by yourself. Just write a tree. First of all, no need to draw the tree. No need to visualize the code via a tree. Visualize the tree through the code. Okay. Yes, Sumit, they are enough. Um, yes, Naika, that's true. Okay, so draw any random tree, and after that you dry run that tree using the code. Okay, and then you will see how things are going inside the stack and how they're coming out. So that will help you get an understanding of how the iterative version is actually working. Okay, so I want you all to do the same thing because see, all these things from interview point of view, they are important, and you have to kind of just learn up all these things. Okay. Hmm. Okay, yeah, thanks. So this was from my side then. Okay, then let's see you tomorrow at 10 p.m. and a very good night till then. Bye bye.